Latent spaces of generators contain vast landscapes that are only just beginning to be mapped. For artists working with GANs, generating imagery involves visualizing points in this structured high-dimensional space, so navigation is crucial. For instance, imagine finding yourself somewhere on the coast. How can you reliably steer toward rocky or more mountainous terrain if, whatever coast you land on, that's the direction you'd like to head? Our tool, the Latent Compass, allows creators to visually steer through GAN latent space along directions of their own devising. Calibrating the compass turns a perceptual experience, similarity, or difference into a transformation that can be applied to any image. To capture the visual difference between rocky coasts and ocean views, I've dragged examples of each class to the right and left of the screen. Now we choose a scene-level transformation to find a corresponding dimension in Z space that will allow us to head toward the mountains or the ocean from any coast. Let's look under the hood as the compass calibrates. This version of the Latent Compass uses BigGAN trained on the Places dataset, containing 365 categories of visual scenes, but the approach itself is broadly compatible with other generators. Within some category, a user browses concept space in a pool of generated images to identify images that correspond to a visual dimension of interest and sort them into two groups. That dimension is entirely user-specified, in contrast to methods of direction discovery that use off-the-shelf classifiers or search for a few familiar image transformations. Here in this example, we can decide to tease apart the difference between lush, verdant lakesides and their wintry, less fertile counterparts. Based on this sorting, a linear SVM is trained to construct a separating hyperplane, and a normal to this hyperplane is identified as the direction, D in this figure, capturing the corresponding feature of visual experience. Any image can then be transformed some amount along this dimension by passing its modified Z vector through the generator. Now let's try transforming a few different coastlines. We can drag any starting image to the center of the map and automatically generate 3 transformations in either direction, toward a rockier coastline or toward the sea. By clicking the arrows to the right and left, we can take further steps in either direction, and clicking an image removes it from the map. Our navigation is not constrained to coastlines. We can apply the same transformation in different categories and add mountains to a lakeside or turn toward the water. We could also decide to make more fine-grained changes to an image. In addition to using an SVM to drive changes in Z, the Latent Compass can intervene in intermediary layers and modify parts of the GAN's representation, differing from related approaches which use the entire distribution modeling property of the generator. By training a classifier on unit activations in an individual layer, we can manipulate those activations along user-specified directions, producing image transformations that are more fine-grained than those in Z-space. Let's try it on another example and see if we can capture fullness in closet space. The fullness representation is sufficiently abstract and object agnostic to translate to an outdoor marketplace, where people are added and removed rather than clothes. The compass enables features grounded in some domain to generalize to new artistic contexts, turning a user's visual experience into something replicable and executable. We invite creators to experiment with distilling high-level, wordless representations of their own visual experiences into directions that can be traveled from anywhere.